Hello, everyone. Thank you for joining us today for our live session on predictive modeling through spatial analysis and data science. This session is part of our National Government webinar series. My name is Noelle Loughran, and I am a marketing specialist on Esri's National Government Industry Solutions team. And I would like to let you know that today's session is being recorded. All of you will receive an email with a link to the recording tomorrow from GoToWebinar. We will be answering any questions you may have during today's session. Please use the chat window in GoToWebinar to enter in any of the questions you have. And once we're done with the presentation, we'll get to those one by one. We will also be providing 2 polling questions during today's session. Those are interactive and you can click on the answers on the screen. So we will have those pop up as we ask those questions. And from there, I'd also like to introduce our speakers to you. So we have 3 experts from Esri here with us today. We have Kate Hess. She is a solution engineer for the Geospatial Authorities team here at Esri. We also have Rami, who is a solution engineer also for the Geospatial Authorities team, and Linda Peters, who is our Global Business Development Manager here at Esri. So with that, I'd like to pass this over to Linda, and she can get us started with the agenda. Thank you.
Thanks so much, Noelle, and welcome everybody. Really glad you're here. I'm going to shut camera off for bandwidth considerations, but I'll come back to you at the end when we get to the Q&A portion. I would like to go over with you today's agenda. So we are here to talk about spatial analysis and data science. There's going to be a lot of good demonstrations for you today, but we're going to start out with a little context on data science and GIS. And then I'll invite Kate and Rami to show you those great examples. As Noelle mentioned, we'll have a couple of poll questions along the way. We're going to share a lot of resources with you, and at the end, open it up for questions. So we hope you're ready for us. Let's start, as I always tend to, with the ArcGIS system, because although we're here to talk about spatial analysis and data science, it starts with the ArcGIS platform. Many of you know that ArcGIS is a comprehensive platform. It's open, it's services based, it's distributable, it's extendable, and it supports large organizations and also individuals. And it really provides us with a smarter way to perform analysis. So as we think about spatial analysis and data science, these are at the heart of what most GIS professionals do. It's about solving problems and advancing science. This year here at Esri, we've added a lot of new tools and improved existing ones. We introduced many new algorithms, new tools for AI and machine learning and big data and scripting, and some great tools for data engineering. I want to underscore those. There are some really great new tools for data engineering as well as forecasting, including a method to allow you to evaluate forecasts by location and choose the right method, whether that's curve fit or exponential smoothing or random forest, based on your data. And we did already a great webinar on that. So if you're interested in that, take a look at our webinar series and take a look at those tools. But today, we're here to talk about some other areas. And the innovations and advances in GIS analytics are allowing us to really see some of these new patterns and create insights with predictive modeling and analyzing of spatiotemporal information. The ability to enrich our data with GeoAI and machine learning is just incredible. And the ability to perform advanced raster analytics as well. And we're going to touch on a lot of these areas as we get into our demonstrations. I want to remind you to think about always the spatial analysis and data science framework as well. We need to think about our approach. My colleague Lauren Bennett likes to say, you know, we don't just do data science. We start with a problem, we identify the people that we need to work with, we find and prepare the data, visualize, explore, and analyze that data, and then use the chosen method to help us get to an answer. This could be via clustering, for example, or classification or a regression analysis. And the reason that we do this, again, is to understand perhaps what has happened, what could happen, or what we should do. We use it to solve real world problems, to answer questions. And that could be descriptive, predictive, or prescriptive. So we see this very clearly over the last 18 months, I think, with the use of dashboards, helping us to understand, describe, and predict what was happening with COVID as it spread around the globe. Now, I don't want to spend too much talking. Again, we've got some great demonstrations for us. We've got some great things to share. We're going to touch on deep learning, training data, population estimation, network analysis, hydro analysis, DEMs, cost surface analysis, a lot, as you can tell. So with that, I want to ask my colleague Kate to get ready with that first demonstration. But Noelle, can I throw it over to you for a first poll question?
Yes, and let me launch that. So this is a question where you can select all the answers that apply, and we're interested in understanding what area would you be most interested in learning more about in spatial analysis and data science. We'll keep this open for a little bit so all of you can enter in your responses, and then we will share them with all of you when we're done.
Yeah, and there's so much that's important here. Again, we want to understand, what's most important to you. We heard a lot about data engineering earlier this year, but really want to understand, where are you at in your process today? What's important to you?
Right, I'm going to go ahead and close this now and share those results. Thanks for responding. And wow, Linda, it looks like a lot of people here are interested in learning about the spatial analysis, modeling, and scripting. So that's pretty
Great.
promising. Yeah. All right, I will go ahead and send this back over to our presenters. Thank you.
Yeah, Kate, over to you.
Great, thanks. So today in our demos, we're going to be looking at the general theme of access and how we can calculate it with different levels of data availability. I'll start with a high data scenario in New York City, where we have fine-grained population data, in this case through the business analyst tools, and detailed network data from ArcGIS StreetMap Premium. After that, we'll look at vaccine site access in Uganda using the distance accumulation tool and Esri's population estimate data. And then finally, we'll start from imagery over a Rohingya refugee camp and use deep learning to extract tents, then calculate access to washrooms and see which tents are at risk of flooding. So first, let's look at New York City and access to green space. I have a point layer here with all of the entrances to parks in the city. We're going to take the detailed network dataset that's available for New York City and bring it into our network analysis tools. Within these tools, we have a few different workflow options. So we could find the closest park to a specific building, we could do route optimization, or we could pick the best place to locate a park based on the target demographics in the surrounding area. But today we're going to do a service area analysis to find out which areas and then how many people are served by each park in New York City. In order to calculate a service area, once it loads in here, all I'll need to do is add my facilities, so in this case, the park entrances, and then select my mode. We have a few different options to choose from here. So there's the normal driving time and driving distance, there's a different setting for emergency vehicles, and then other options for rural driving distance or trucking driving distance, where it's going to take into account different features of the road segments. But today we're going to take a look at walking time and see which areas are within a 5 and 10 minute walk towards a park in New York City. This tool also has the option to specify a specific date and time or day of the week. As you can see, the data that we have for New York City includes live traffic data as well as historic traffic data. So we could take a look at how the conditions differ if I'm trying to get to a park on a weekend or maybe in the middle of a weekday. But today we'll just keep it more generic. When I run this tool, I get an output showing all of the 5-minute service areas that are areas where I can walk from within 5 minutes to any point in these polygons and get to the park entrance. If I zoom in, I can see how this is using the network data set. For example, here, the access polygon is not a perfect circle. It's going to be shaped specifically around the different roads that people have access to walk towards the green space. Now that we have the areas that are within a 5-minute walk of green space, the next step of our analysis will be to find out who lives in these access areas. Now, because there are some overlaps where people are within walking distance of 2 parks and we don't want to double count them, I've already run the dissolve tool so that we have just one layer covering all of the 5-minute walk areas. In order to add population data to our 5-minute walk time service areas, we're going to use the enrich tool. So I can see for this geographic area, we have access to lots of different options for demographic variables. I could explore these by category, or I could search across all of the variables. So we're interested in population. We have data available here from different sources. So I'll take the 2020 population estimate from Esri, and then I'll take a US Census data set on the number of households. We could also look at information on the how equitable access is. So I could look at households above and below the poverty level to compare how many people in each category live within a 5-minute access to a park. Once I've selected my variables, I can run this tool, and it's going to add that data directly to our enriched polygon, or directly to our dissolved polygon layer. So now I can see that for all of the areas falling within these polygons, there are 4,266,000 people who live within a 5-minute walk of green space in New York City. And we could continue with that analysis further to compare the demographics of those living closer to a park to those who live without easy access to green space. Another way to visualize this data is to use census block groups, which we can download from the Living Atlas. Here I have sized each point by their block group population and then colored them with the walk time data. So anything in light green is going to be within a 5-minute walk of a park, dark green is within 10 minutes, and red is further than a 10-minute walk away. So now we can see at a glance where there are areas of large populations without access to green space. I can publish this map and share it with decision makers, using the power of GIS and spatial analysis to identify a pattern and then bring attention to a problem. Now, this use case in New York has been an example where I have all of the data that I need easily accessible. We had accurate population data all the way down to the block group level, and that detailed network layer that included details like traffic patterns by time and day. But in many cases, this level of data is not available. Luckily, with a different set of spatial analysis tools, we can still calculate access and make maps to drive decision-making. For our next analysis question, we want to see how many people are being served by the current vaccine distribution sites located in the Gulu district of Uganda. Before we get into our analysis, we need to check the data availability to determine the best methods for our analysis. We can check demographic global data coverage, and we can see based on the legend that there's some data available for 2019. But when I select Uganda, I can see that this only goes down to the district level geography. So this isn't going to be enough when we're trying to look at access within one specific district to these different vaccine sites. We can also look at the Street Map Premium coverage in this publicly available map, and we can see that for Uganda, we're only going to have major roads available, unlike the highly local roads we had in New York City. So even with this amount of data, we can still quantify vaccine accessibility in the Gulu region of Uganda. We're going to use the highways that we already have, combine that with slope data, land cover, and rivers, and perform spatial analysis on these geographic features in order to calculate access. And our ultimate goal here is to identify which areas and then how many people are within a 1-hour walk from the vaccine sites. To more accurately calculate the distance walkable in an hour, we're going to create a cost raster. So this raster will have a value for each cell indicating the cost, or essentially the difficulty, of traveling through it. To create this raster, we're going to take the 4 layers that we already have as our source data sets, the highways, land cover, rivers, and slope, and then we're going to reclassify them on a scale of 1 to 10, where 1 is the lowest cost to traverse and 10 is the highest or hardest. So in my reclassified rasters, you can see that we've simplified this data. Now I can see that the southern sections of the district that are mostly cropland are going to be easier to walk through than the northern areas that are primarily forested. You can see in the legend that we've also set rivers as the hardest to traverse and highways as the easiest. Now that I have my 4 reclassified inputs, we can run the weighted sum tool to combine the weights, giving us 1 value for how difficult it is to cross each cell. And in that cost raster, we can now start to visualize which sites will be easier to travel to in green. To take this further and to get a walkable area for each vaccine site, we will input our cost raster into the distance accumulation tool. Now for this tool, we're going to use all of the data that we've put together so far. So our feature of interest is the vaccine sites. The barrier is going to be the rivers. Our surface raster will be the elevation. And this elevation raster is what's going to be used to calculate the actual surface distance that's been covered when people are traveling through these cells on their way to the vaccine sites. The cost raster is made up of all of the different factors that we just talked about. And finally, I just need to indicate that the maximum accumulation, or the total distance we're going to travel, is not going to exceed 1 hour, and that we're traveling toward the vaccine sites. Now, when I run this distance accumulation tool, I get an output that looks pretty similar to the output layers we had from the service areas analysis in New York City. And we can immediately see that the areas accessible in the green parts of the map are larger than those in the yellow parts of the map, which is as we expected from our initial look at the data. Now we want to know how many people are being served by these vaccine sites, but we don't have the detailed demographic data like we did for New York. In cases like this, we can use additional data sets like Esri's World Population Estimate layer, which we can access from the Living Atlas. This dataset was created with a model that combines imagery, road intersection density, populated places, and urban footprints to create a raster of population with a cell size of about 250 meters. The population then of each polygon within a country was normalized to the UN's population estimates for each country to further ensure its accuracy. When we load in this data, we can start to see how it will line up with our vaccine access sites and further explore it. So we're expecting the highest population to be in the city of Gulu in the middle. And if I select a cell in the middle of the city, we can see that about 280 people live within or nearby this 250 meter cell. And then I can compare that to somewhere further from the city and see that just 112 people are living in this cell further from the main city. Now, to get a more accurate count of the number of people served within each access area, we can use the zonal statistics tool. So for this tool, all we have to input is our feature data, so the world population data, or in this case, that will be our 1 hour walk accessibility, Then we'll look at the population estimate, and the output will show the sum of all of the population cells that fall within that polygon of walk accessibility. So when I run this tool, we get an output where I've colored each of these different service areas by the number of people that they serve. And we can immediately see that 3 of the different vaccine sites are not going to be within an hour walking distance for any of the citizens of this area. And this is at least based on the Esri population estimates. But these are sites that we may want to consider relocating so that we can better serve the Gulu population. With this analysis, we were able to answer our question of how many people are being served by the vaccine sites in Gulu without a sophisticated network dataset or high-resolution population data. This is the power of the spatial analysis tools. They allow us to solve problems with different levels of input data. Now, to further illustrate this, I'm going to pass it over to Rami to do an accessibility analysis for a refugee camp.
Thank you, Kate. Hello, everyone. Thank you for being here today. So, through our presentation today, we're going to go through another workflow of spatial analysis that we're going to study the Rohingya refugee camp. And to start with, we wanted to focus on SDG 6, which is ensuring availability and sustainable management of water. Under this SDG, there's 8 different targets, and we're going to be touching these targets through our analysis. To start with our analysis, we had to pick up our study area, and for that, we focused on the Cox's Bazar region, which is on the borders of Myanmar and Bangladesh. And if we zoom in, this region hosts something around 1 million refugees, and we wanted to focus on a small area for the availability of data and to ensure that we're getting the best out of the tools. So as we go forward, we had to ask a couple of questions for our analysis. What % of population live in the most critical areas of flooding? How many washrooms and latrines are located within the most critical areas of flooding? And what % of refugee camp do not have access to a washroom within a 2.5-minute walk time? To answer question 1, we were able to find that 27% of the population actually lives in flooding area, which is a really high number for refugees. And from within this area, there's around 100 latrines and 45 washrooms that are in critical flooding risk. What we're seeing on the screen is a dashboard that is showing the end results, and we're going to be going through the process on how we got here. But to start with, the dashboard is telling us where are these washrooms, where are they sitting in the highest flood areas, and then it's telling us how many people are sitting within these tents. Moreover, if we go to question 3, there's 24% of the population that actually lives in more than 2.5 minutes walk time to get into a washroom, which is alone a big thing. The dashboard we're seeing on the screen is actually telling us where are these tents, who got access and who doesn't, and who's living within a walking distance. In our study area, there's an estimate of 32,000 people living there, and we can see that 11,900 of them doesn't really have access to washrooms. So to start our analysis, our first challenge was to find data, reasonable data for refugee areas. And for that, we wanted to utilize the power of deep learning within ArcGIS Pro. We were able to get hands on publicly available drone imagery by IOM, or International Organization of Migration. What you're seeing on the screen is a sample of this drone imagery, and what you're seeing in blue is the first run of the deep learning model. We use an out-of-the-box deep learning model that is available in Living Atlas for Africa. And since this model was trained in Africa, we weren't expecting to get the best results. And you can see that in the screen. The model is actually detecting a couple of buildings, but it's not giving me the full story of what I see. It's missing tons of tents, and I want that. So in order to accomplish that, we had to retrain the model. And to retrain the model, we had to digitize all of this area, which is approximately 3,000 refugee tents. It took us a while to digitize this, and then we used the export training data for deep learning in ArcGIS Pro, which you can see on the screen. Through a certain metadata format, we were able to export these chips that are labeled with the data we want. Moving forward, we trained our model through trained deep learning models in ArcGIS Pro. We inputted the training data that we exported, and we ran the model. It took around 20 hours to retrain the model, and the reported accuracy is something around 85%, which means that from the images that we've got, the model will get something around 85% of the buildings. Moving forward, we had to test the model. And we're going to start with the first initial view, the model from Africa, and this is a complete different area. So as we're seeing here, yes, the model isn't giving the best results, but what happens after we try our model is pretty fascinating. We're able to locate these tents tent by tent and get pretty accurate results. So if I zoom in to take a closer look, I'm going to see that the tent's footprints are there, and they're pretty accurate. We're seeing that the edges aren't smooth, and this is because this is the raw output of the model. In further analysis, we'll be able to QA, QC this data and make use of it. As we move forward in our process, we wanted to label these tents. So the first step was actually regularizing the tents so we can see these edges smooth and looking nice and having a good footprint. The second was how can we classify these tents? How can we get what tent is used for? For that, also IOM shared a camp facilities layer. In this layer, there's different uses, the points you see on the screen, and they vary across washrooms, latrines, water tanks, mosques, etc. We use the spatial join tool with our tents in order to get the use of each tent. So at this point, each tent, each footprint that we extracted got a use. We labeled everything and we got the refugee tents. So everything in red is actually a tent that is occupied by people living in it, and everything else is services and facilities. We zoom in and take a closer look. The tents look good. And what we're mostly interested in for the analysis today is the blue ones, which are latrines, washrooms, and toilets, and the red ones, which are refugee tents. As we move forward in our analysis, we wanted to get an estimate of the population. And this was a little bit of a tricky part. But gathering some data, we were able to locate that UNHCR estimates that in the Rohingya camps, there's approximately one person living in every 8 square meters. And we got the areas of the tents, we got the tents classified. That helped us with a little bit of Python. We utilized the search cursors and update cursors function. We were able to estimate how many people are living within each tent. So in our area of interest, there's approximately 32,000 people, and they're divided across these uses. As we move forward, we also mentioned the washrooms, and we wanted to know the washroom capacity. Another UNHCR KPI says that each 6 square meters of a washroom usually can accommodate for approximately 7 households per day. And an average household in the Rohingya camps is approximately 6 people. So doing the math over the population and utilizing Python again, we were able to get how many households we can accommodate for, and that's around 3.4 thousand, and how many households we've got, which is 6.9 thousand. And that's the first triggering thing. There's a lot more households than the washrooms in such an area, which means that the people aren't really being served enough for the refugees. Moving forward in this analysis, after we located the things we're looking for, the tents uses that we're looking for, we wanted to go further and understand who is at risk. And to answer these, we started with our flood risk analysis. In the flood risk analysis, we were able to find these contour lines on HDX, Human Data Exchange Hub, which is a high resolution contour lines that's approximately 1 meter. We were able from these contour lines to derive the digital elevation model you're seeing here, which I bet a lot of you who do spatial analysis are pretty familiar with digital elevation models. After we got the digital elevation model for our area, we were able to utilize one of the learned lessons that is available for you to help us predict floods with unit hydrographs. Walking through this analysis, we were able to create the watershed that we're seeing here with the flood areas and locate the high risk flood areas, and these are in the blue. The tents that overlay them are those tents that are at risk. I'll jump to ArcGIS Pro and show you what's been done here briefly. So we've created our watershed through Pro, and then we got the tents that are intersecting our highest risk. We have all the tents in the flood zone, but we're more interested in the ones that are at high risk, which are these. And then from these, we filtered the refugee tents and the washrooms. So if I take a closer look at this, I'll be able to see that, yes, these are all at risk. And I do have estimate of population of these that are at risk, which we saw in the first dashboard. To do this, we've actually utilized Model Builder, and it's a one click that helped us automate the whole process. I'll jump back to my story map to keep going. The next step was to create a network analysis or a network data set in order to figure out from these tents who got access, who is within the proximity, and who's not. To create the network data set, we utilized OSM data that is available for the Rohingya camps, and we used this model builder, which goes through the process of filtering the roads within our area of interest, creating the network data set, and giving us a final network data set. This network data set got two main components, which are the walking time. That's a KPI also derived from the sphere minimum standards and indicators for humanitarian response, which says 83, like in a refugee area, in a walkable area, you can do around 83 meters walking per minute. And we embedded that into our network data set in our costs. The next thing that we did is we actually made sure that the DEM is in the network analysis or the network data set, because the area is a slopey area and the variation of slope might get people to the place in a longer time. The next step was we wanted to test our network data set, make sure that it's giving us good service areas, and that's what we're seeing on this screen. Dropping a point, seeing how far is the distance, seeing if it's getting the distances in the right numbers, and so on. After getting that, we had to plug this network analysis to our raw input data for the refugee tents that we created and the washrooms. We specified the 2.5 minutes matrix, and then we used the allocation tool. This is a very complicated, looks like model, but the end result of that model looks interesting because we were able to flag these tents, and we're able to see that anything in red is more than 2.5 minutes, anything in orange is at risk, 1 to 2.5 minutes, and anything in green is well served. So as we can see, all these red tents aren't actually being served. They don't have accessible washrooms, and that will create a huge issue for the people living within these areas. That's it for me, and thank you. I'll give it back to Linda.
Yeah, thanks, Rami. That was really great, and I know there's a lot there to unpack. I think Noelle, why don't we do our next poll question, if you would?
Yeah. So we are now asking you to choose one of the following. And we are interested in understanding if you are using data science methods or spatial analysis in your organization today. We'll keep this up for a few moments so everyone has time to reply.
Yeah, we saw so many great things there with the work between Kate and Rami and different methods and different levels of granularity of data that's available. I think this area of data science is just exploding, and it's really exciting to see the work that you all are doing as well. So again, we just want to understand where you are in the process and how we can help.
And with that, we will go ahead and close the poll. and share the results. And a majority of our audience today says that you have been using it for more than 12 months. So that's fantastic to hear. So there was a lot of yeses in this session today.
Good. A lot of advanced users. Great. Well, thanks again for that, Noelle.
Of course.
I'm going to move us forward. I want to make sure you can see my screen okay. So I want to just sum things up a bit for us because
we don't see your screen yet, Linda. Sorry for interrupting.
That's all right. That's why I was double checking.
There we go. Perfect.
All right.
We can see it.
Good, good. So I wanted to sort of sum things up. I mean, we saw a lot of different types of analysis in there, and this is important for us as, you know, we're working in our organizations today, and everybody's being asked to do more and to deliver information much more quickly, and everybody wants better resolution and higher quality data. And so that's our challenge. And how do we do that? You know, and maybe we're doing that with less people in our organization or less time as we're being asked to do more and more. Hopefully what you saw here is how some of these tools can really help you become more responsive and speed information to those decision makers by using this technology and you know, data analysis and data science. You're able to do much more and increase your efficiency and expand your capacity, right? Being able to do an analysis like we just saw in Rohingya, you know, now that we've done that, how can we share that information to the decision makers, you know, and help engage at the community level and make an impact. So with that, I do want to leave you with a lot of resources. And again, this is being recorded today. We will share the recording. We will share the slides. We will share all of these great links. Lots of things out there for you to get your hands on, including a great story map, you know, the Refugee tent deep learning package, which is out there now as well, and some of the other things that you see on the screen. And of course, I want to point out our Learn lessons as well. A lot of great stuff in Learn, as Rami had highlighted. So with that, Noelle, I think we want to throw it open for a Q&A session. So I'll throw it over to you.
Great, thank you. And I'm going to turn my camera back on now. So first question is for Kate. So what our audience is interested in knowing is if the Esri network route only along, does the Esri network route only along segments that have sidewalks? There we go. I can read now.
So the network that I was using was the built-in ArcGIS Online option. So that one does not put an emphasis on sidewalks, but the power of the network analysis data set or the network analysis tools is that you can also bring your own network data sets to them. So if you had a sidewalk network, you could load that in and do the analysis on your specific sidewalk layer. Or if you had your own road network, maybe for a country where the ArcGIS Online data isn't available, you can bring in your own data to run the same kinds of analysis on it.
Noelle,
No,
I think you're muted.
That's embarrassing.
Okay.
I need to give it a minute. There we go. Okay, sorry about that. So Linda, next question is for you. Is there a free version of ArcGIS Pro for students, or is there a package with student pricing?
Yeah, great question. What I would say is check with your university. Many universities have site licenses and accessible licenses for students. Of course, you can ask one of us too. So if you'd like, you know, us to check in, let us know what university you're with. We can let you know that. There's also other ways to get access to the technology, a personal use license, perhaps. So yeah, reach out. We can help you find that answer.
And Rami, this one is for you. Is it possible to show how you imported the IOM drone images into ArcGIS Pro into the ArcGIS Pro environment?
I can share my screen, but I can tell it. It's pretty easy. So if you find the IOM images, which you search refugee, if you do research on Google refugees IOM and ArcGIS, you'll find one of their web apps. And in their web app there, you'll get the link for the layers. And if you click the layers, you can show details or show item details. And the item detail will take you to the service. That service, you'll only need to copy the link and go to ArcGIS Pro, add data from URL, and you'll paste that URL there, and the image is in your ArcGIS Pro.
Perfect. And I think this is a good time to remind everyone that we are recording today's session. You will have access to this recording tomorrow, so you can always replay that response if you need that step-by-step walkthrough. And actually, Rami, this next question is for you. The details of the analysis blew by in seconds. It would be most helpful to be provided the actual notebooks and models to poke around and review how the numbers were generated. Is that possible?
It is certainly possible. In the resources that Linda shared, we have the different models that we used along with the ArcGIS Pro packages and along with the deep learning package that is out there. So you can recreate this analysis on any other different area, and also feel free to reach out to us in case you hit any road bumps, and we're more than happy to help you.
Yeah, and I'll just add, I've dropped a couple extra links in the chat here in the GoToMeeting. So there's really good documentation for all of the tools that we used, or that especially I was showing in Pro, that go into what are the defaults. If you just leave all the defaults, what are those values and how did they come up with those? So there's a lot of good information there on what goes into those analysis in the background.
I have a question for you, Kate. Can I use network analysis tools with OpenStreetMap?
Yeah, so there's OpenStreetMap data sets, like network data sets that you can download and then bring directly into the tool. So that's another really powerful option to use in the network analysis data or tool set.
Also, to add on what Kate said, so in the Rohingya refugee tent example, we actually got the raw roads from OSM, and we were able to create our network data set from OSM data.
Excellent. And Rami, where did you get the estimated density for Rohingya?
This is available in a story map shared by UNHCR for the Rohingya camp refugee counts. They estimate per camp how many people are living. And also on Human Data Exchange, there is some estimates for the camps.
Excellent. And Kate, how can I see what population data is available for analysis?
So a great place to start is the Living Atlas. That's where I found the Esri World Population Estimate dataset. And there's a lot of other data sets available through the Living Atlas, both that have been created by Esri and that have been shared by others. The Esri data, when you select it in the Living Atlas, you'll see a really detailed explanation of the methodology of how we came to those population estimates. And there are also blog posts that go along with those to really go into the details of the analysis that got us to those population estimates.
Yeah, I might add just to what Kate said. There are a ton of really great resources that we publish, and some commercial providers that provide data. But look for your own country data as well, right? We're starting to see really great sharing of data from authoritative data sources such as INEGI in Mexico and others. So you know, it's worth to take a little bit of time and look around and see what you could possibly leverage.
Excellent. And one last question for you. Oh, actually, there's a couple of questions that came in. So Rami, this one's for you. Can you share the training data for the Refugee project, or is there a new model as a result of this?
The model is actually the one you're seeing on the screen shared, which is Refugee Tents Detect Deep Learning Package. I actually shared that, and it's available public for you to download. So I can share the data, but it's around 1 to 2 gigabytes of data that they're already in the model. So, but in case there is need for that, I can even share the service that is out there.
Excellent. And so Rami, this one's for you. Do you upload your projects and codes in the Esri official GitHub page or your personal GitHub pages?
Unfortunately, this code isn't on GitHub, but there is an effort to get these onto GitHub pages where we share them with public. For now, what we uploaded is packages, ArcGIS Pro packages, where you can find the tool sets in ArcGIS online, and they're available public, so you just need to download.
Great. And Kate, this one's for you. When someone uses network analysis, sometimes the roads are generated where, okay, hang on. Let me read that one more time. The text is so small. I'm sorry, everyone. When I used the network analysis, sometimes the roads I generated were in the beach or the ocean. How can I solve that?
So we would need to know a little bit more about the input data and the specific workflow to know for sure. But you can clip your output by if you have like a polygon that's the extent of the area that you're interested in. That would be my first troubleshooting step. But yeah, I would really need to know what the input data is and what the workflow is to give a better answer there.
Excellent, thank you. So with that, Linda, it looks like our Q&A is complete. We don't have anything else coming in.
Great set of questions. Again, thank you all. Really appreciate the engagement and the set of questions. Again, I'll point out the many resources that are available here and encourage you to go take a look at those. Some really great models for you to leverage in your work. And again, we appreciate all of you being here with us today. Noelle, I'll throw it back to you to close it out. I do see one other question coming in. If their university doesn't have a license, in that case, again, I would encourage you to look at perhaps a personal use license. But again, if you want to let us know, where you're located, we can try and help you solve the question there.
Yeah, thank you. So thank you, Linda, Kate, and Rami for all of the great information today. Thank you to everyone that attended and gave us some of your time. And I will repeat it, we did record today's session. All of you will receive a link to access this recording tomorrow. It will be posted on our Esri community. We'll also have links to all of the resources that Linda just shared. We also have the we've also in this recording post, we'll have the ability to let you ask more questions or chat with any of our speakers here today. So if you have anything else later on, please feel free to reach out to us through there. We also have our emails included in the post-webinar email that will come out from GoToWebinar tomorrow. So with that, thank you again. And yes, there is a survey that will pop up on your screen when we close today's session. So if you have time and if you have the ability, please respond to that survey. It will help us improve these sessions or help us improve on future sessions. So thank you so much. And we hope to see all of you again soon. Thank you.
Thanks all.
Thank you.
Thanks all.